Welcome back everyone. Today's video is an explanation of problem F from the AtCoder Beginner Contest 312. I have provided the correct Python code in the video description, so please check it out after listening to my explanation. Let's begin with the problem statement. We have three types of items: portable cans, regular cans, and can openers. There are n items in total. Can items have happiness? When we choose a portable can, we immediately get its happiness, but we can get it from regular cans after using a can opener. Each can opener has a limit of use. We choose m items out of n. Our question is to find the maximum happiness among all the combinations of m items. Here is an example where n equals 12 and m equals 5. If we chose 5 items in this way, we can't open both regular cans, so the happiness is computed as 21. Let's proceed to solve the problem. First, when we choose items in an arbitrary manner, we should select high-valued cans, and can openers available for many cans are more useful. So we sort each item list in descending order. Next, we find that if we fix the number of items for each item type, it seems to be easy to calculate happiness. For each item type, the way to achieve the maximum happiness is to choose items from high-valued items. The problem can be reduced to a question about cumulative sum, and for each tuple, we calculate it with the order of 1. Therefore, we want to iterate three variables x, y, and z, representing the number of items to choose from each category respectively. Now, we have x plus y plus z equals m, and it's sufficient to move two variables out of 3, but it still takes the order of n squared, and it exceeds the limit. Instead, we should fix a variable out of 3. Then, here is a question: which one should we fix? In this video, I will explain a solution fixing the variable y, which is the number of regular cans to choose. The advantage is that the best value for the variable z, which is the number of openers, is easily determined by y. We must open y regular cans because we have already decided to select y regular cans, so z should be the minimum number of openers to open them. We can calculate such z by bisect, and I will explain it in the next slide. Then, the variable x is calculated as m minus y minus z, and the happiness for the x, y, and z can be calculated by cumulative sum. In this way, we will get the maximum happiness after iterating the variable y and try this algorithm. Let's move to how to determine z. Our method is using cumulative sum and bisect. Before beginning to iterate y, we prepare a list named cum that records the sum of regular cans we can open when using can openers from the first to the i's. Then for each y, the best z is the minimum index I of the cum list satisfying y is atmos cum of I. Check the above example if you don't get the idea. When we use bisect on the cum list, specifying z takes only logarithmic time, but we must be careful when y is so big. We can't always open all the regular cans even if we use all the openers. So we mustn't search for Z where Y is out of the cum list. Finally, I will explain how to calculate happiness for the fixed x, y, z. We again use cumulative sum. The total happiness is x brutal counts plus y regular counts. So we should make a list named cum1 for calculating brutal counts in advance. But since we iterate y, we don't need to make the cumulative list for regular counts, but just define a variable sum and increment it every time we update y. Then happiness is calculated as cum1 of x plus sum. I have finished the explanation of the algorithm. Here are some comments. First, the total time complexity of the algorithm is n times log of n because we iterate y from 0 to at most n and bisect on a list with a size of n. It is about 10 to the 6th and it's acceptable. Second, we can find the best z without using bisect, and we reduce the order of the time from log of n to 1. Try to improve it if you are willing. Finally, we fix the variable y at first, but this is not the only way to solve the problem. Whichever variable we fix, we'll come to a solution, but fixing y is the easiest. I also provide a solution fixing z in the video description, so please use it as a reference. Now I have completed the explanation. If you have any questions regarding the problem or any requests to solve other ABC problems, please feel free to comment. Thank you for watching the video.